Hi everyone, I'm Sangwoo. In this video, I would like to share how to calculate three types of correlations and their statistical test. As you know, the Pearson's correlation is useful when we measure linear relationship between two variables. And Spearman's law is the non-parametric version of the Pearson's correlation. And it is less sensitive measurement because it uses rank of raw data. And it determines the strength and direction of the monotonic relationship between two variables. The Kendall's tau is a statistic used to measure the ordinal association between two variables, and it is also non-parametric. Especially Kendall's tau b is useful when we need to adjust for ties. As you can see, there are three practical statistical tools which provide these three types of correlations in the analysis module. This is as you can see Kendall, Pearson, and Spearman. In SPSS, you can choose one of these options or all of them. In R, you can use cor.test, and there is a method Pearson, Kendall, and Spearman. Let's move on Pearson's correlation first. I have prepared 20 samples data to calculate Pearson's correlation, Spearman's law, and Kendall's tau b. Here is Carl Pearson. So I will show you 4 ways to calculate correlation coefficients. So this is the first formula. The numeric part is covariance. So S, select first array, comma, and select the second array, and over sigma x and sigma y, dev.s, and sd dev.s. Right. The second method is this one. So we need to calculate x minus mu x and y minus mu y by using sample data. So x minus bar and press F4 for y minus y bar. Right. So we can use sum product function, comma, select second one, comma, and over n minus 1. There are 20 samples, so n minus 1 is equal to 19, and over, and sigma x and sigma y. Multiply by right. The third method is using is this one. So the denominator part we can consider dvsq function. So some product, comma, and over sqrt devsq and multiply by this one. Right, the final method is the simplest method, I think. So we can use correlation function in Excel. First array and comma and second array. All right. We also can test it statistically by using this formula. So this is T statistic. It follows T distribution with n-2 degrees of freedom. So T statistic can be calculated by R multiplied by SQRT and n minus 2, which is equal to 18, and over 1 minus R squared. Right. So for p-value, we can use t distribution. So t dot dist dot 2t because two-sided, and this one is t statistic is x, comma, and degrees of freedom is n minus 2, so it equals 18. Right. We also can calculate confidence level by using this formula. So I got this paper from this website. So for transformation part Z can be calculated log 1 plus R over 1 minus R and over 2. Okay. For upper image, let's use this one. So Z minus Z 1 minus alpha over 2 can be calculated this one minus and norm inverse 0.975 because alpha is equal to 5% and multiply by SQRT and 1 over n minus 3 equals 17. Right? I just missed this one, comma, mean as 0 and standard deviation as 1. Yeah, and for upper limit we can use same formula, but let's change minus sign to plus sign. Right. So finally we need to change scale for calculate correlation part. So for lower exp exponential and 2 by low of z, this one, and close the form, and minus 1, and close the form, 1 over, and exp 2 multiplied by low of z, this one again, and close, and plus 1. Alright, so for this part, so we can use this formula. So exp 2 multiplied by zu, so this one, and minus 1, close, and over 2 multiplied by, again the same one, and plus 1, and close the form. Alright, so I also ran R program to test these results for Pearson correlation. So as you can see, yeah, so same correlation here, and T statistic 1.7256, 1. Yeah, this one 7256, and p value is same, and 95% confidence interval here. Right, so I showed you how to calculate correlation and related statistic and lower limits, confidence interval, and also upper confidence interval. Okay, let's move on to Spearman correlation.